Hello, welcome back to our course Electronic System Design. Okay, so in the previous class, we had discussed about two topics, that is product life cycle and design processes. And also we had discussed about the development process of the product. And also we had discussed about the overall product design. So what are the keywords that you had learned from those technical aspect of point of view? Here we will go with the help of the two topics. We will discuss about the system architecture. Okay. So first of all, I want to tell you uh, the technical terms. What should have to know before going to discuss about the system architecture. So the terminology, what you have to understand here. What is the system? First of all, a system performs an overall function and typically is comprised of modules and components, right? System means we have to provide an input and it will perform some operation and provide an output. So inside the system, it is typically comprised as a modules as well as components. So by grouping different components, maybe you can call it as a module. So different modules are placed in one place. It should be defined as a system. So modules are actually self-contained complex units that function largely and independent. Okay, so this size, the size of that module, each and every one is very high, very complex, and their functioning also very high. Okay, so components you already know, like resistor, capacitors, inductors, okay, transistors, resistors. So these all are the active and the passive components what you have already learned from previous years. Here components are parts that cannot be broken down further during development. Okay. So we cannot replace them. We cannot break them. But module you can break and place it. But it is very difficult to replace the components because it is very small in size and it is shouldered in the PCB. It is very difficult to broke. Coming to the characteristics of your devices, complex devices like smartphones, modules, and PCBs are treated as generic systems to generalize the design process. A technical system may be characterized by its relationship with the environment and their required functions and also its structures. Okay, so now we have to know about technical system. We are technical. We are technical. We should know the technical system also. It is a comprised of environment and functions and structures. So now we will see what is an environment. So environment is nothing but it is a physical quantity. You can sense it. Okay. Environment is nothing but a totality of an objects and physical quantities outside the system that relate to our system. Okay. Actually, these environmental relationship generally we can implement it by using inputs and outputs. Now we will see the function. What is a function? Function is a system property designed for a given purpose that converts the necessary inputs into defined outputs. Okay. So under predefined specific environmental conditions. Okay. Like physical quantities, humidity, temperature, sensitivity. So all physical quantities based on that only you are need to can convert your desired function of the system from one form to another form. Okay. For example, I am considering here a printer. So printer is ability to produce a graphical image. Suppose I am giving input as a binary input or binary signals. So binary signal is very difficult to convert it into graphical image. No, it is very easy. You can convert. Structure. Structure here in the sense means structure of a system is the totality of its elements and their interrelationships. Okay, based on all these terms, you can define the characteristics. The technical function characterizes the relationship between anyhow structure and environment. Okay, environment function is depend upon environment and structure. Okay, as a development engineer, you must clearly define the characteristics E, F, and S to describe the product satisfactory in the technical requirement document. So when you are doing the document, you should be defined clearly about these three terms. So each one we will discuss with their block diagrams. An electronic system, for example, must be engaged with the environment, right? To perform their function properly. So here also we are considering in the environment three interface categories between the system and environment for system functionality and their configuration. Why we are interfacing means system with its environment means for functions only. The development engineer needs to engage different environmental scenarios and implement the resulting functional and technical requirements accordingly. All system will not work only same environmental conditions, right? Based on their requirement only, they will perform the operations. So see the simple diagram of the system environment. It is having an electronic system here I am considering. So the input I am providing here. So here IP represent input, I for input, O for output. Okay, input I am giving, output I am getting, right? So here P stands for processing quantity. Here IC is the input, it is a communication quantity, C represent communication quantity. OC represent output, C represent communication quantity. Here also I am providing input as ID, disturbances quantity. O, output disturbances quantity. Okay. This is the diagram for the system environment. We will see what is input, what is output, what is input and what is output. Here we mentioned that we will discuss in detail. Okay. So here in the processing layer or processing quantity, the purpose of system is to execute, process, affect, process, or communicate with the predefined technical operations. The system performs these operations internally by converting input processing quantity into output processing quantity This activity is called as system processing function. What is communication layer? Communication layer in the sense means whether we need to humans have to communicate with other, like the system has to communicate with the user, like that. An information exchange may be occur between the systems and humans, or system to systems, or technical products in technical systems. So many are there. So this operation takes place with the communication input IC and guiding and controlling the processing function, and with the communication outputs as feedback as for monitoring this function. These operations are performed by system communication function. So here disturbance layer is also very important. All non-functional inputs that we are providing, a user don't know about how to operate the systems, they will use all type of buttons. So which means they are non-functional that impact the system disturbances, that is ID, and the environment as outgoing disturbances, that is the OD of the systems. So this layer will handle all this. The disturbances are treated as independent variables. Suitable measures to be need to be put in place to contract these quantities to secure the system processing functions as well as sustain required environmental conditions. These operations are the part of system security also. Now we will talk about system functions also. Here also it is having the three layers. So how the system will be perform number of functions or number of operations based on their capability, based on their number of useful characteristics only, it will depend. So to fulfill their technical functions, the development engineer needs to consider the relationship between the functions. Okay, here we have processing layer, communication layer, and security layer. Otherwise, you can call it as processing function, communication function, and security function. Above how we are mentioned, that is help you to interface between the system and to the environment. So this is the figure you can see here. Communication function, processing function, and security function. Security means if you provide the disturbance, the system has to understand it is in unauthorized function is coming, then we have to uh, recover it. So here for processing function, I am giving the processing quantity IP as an input and OP as the output. And the communication function also you have ICOC, and security function also IDO. So here you can see the term C and M and D1, DO. Can say it is the quantities are internal disturbances. ID and DO are internal and outside disturbances. And C signifies internal control quantities and M signifies the monitoring the quantities. Okay, so each one we will see. The processing function, what it will do, it will convert input functional quantities into output functional quantities under the given environmental conditions. So the conversion is executed, right? The collaborate why how it will be executed means the collaboration between the hardware and software. Information, energy, and material flows all play a role in these functions. So this information flow typically dominates all the electronic systems. Okay. So anyhow, we have two types of functions, primary function and secondary function. Suppose the information processing is generally primary. It's the main function of an electronic system. And it is having the secondary, that is the energy and material processing functions. Suppose a printer is an example. So printer, it will print alphanumeric and graphical information, right? When you are inserting the blank paper into the printer, it will give printed paper. That is material what you have used here, it is the paper. So here electrical energy is converted into mechanical energy, that is secondary processing functions. A communication function may be is the information link between the device and the user. Anyhow, we know. Otherwise, it is a technical system or to the technical systems. Okay. So all these are same. Here we have the security function, right? The security function almost performs three tasks, namely protecting the processing from environmental disturbances and also protecting the system from internal disturbances and protecting the environment from the system faults. Okay. Next, very important, that is also structure. Structure means what? It is a group of elements, okay, so which cannot be decomposed within the system. And relationships, we describe the relationships between the system elements only. And it is also carry out the configuration for the system functionality. Okay, so it is there is doesn't have any diagram. The development engineering should decompose the system into complexity levels depending on the specific design task. For example, designing a system with complex functions means so every engineer should meet their complex purchase parts as a single elements without breaking down for any other. Okay, here anyhow the structure is having some complexity levels. Okay, it is having some single elements, modules, components, varying their degree based on their complexities. Okay, and also components, resistors, we cannot break them. Next, we will talk about system design architecture. So anyhow, system to design, we need modules and components. So modules examples are printed circuit boards and separate standalone groups are connected components. So a system can be designed by using variety of ways, by using depending on their modules and functional and manufacturing requirements. You know, every development engineer should design their architecture early as possible as. Okay. Actually, here the design architectures are influenced by granularity. This is also an important keyword when you are talk about the system design architecture. So this granularity defines the system configurations. That is how many number of elements are there in the system, how the system is to be assembled, how the system is to be integrated in the environment. Okay, so this is also very important. Every engineer should question their himself how my system should be assembled. For assembling, how many number of different elements are needed. Okay, is my system will be integrated in the environment is exactly. So I designed a system without any proper marking, like without any protection. I had taken ISO brand, UNI certified. All these things are there, no. So without considering all these, I just released my product in the market. Means what will happen? Anyhow, I will put less price. What will happen? The user can easily buy because it is a less price compared to other. Then he will place in the house and start utilizing it. Then he may be suffer after few days because if any modular component fail inside the system, he unable to recognize and again he do many number of more number of repairs. So that is not good, right? So every engineer when should he designed any product or device or any small module also, it should be tested. the protection requirement should be met. Without this, all this should not deliver this product into the market. That is very dangerous and that is very harmful to the society. So every engineer should design the products that is useful for the society, not harmful for the society. Okay. Why people are depends nowadays devices means they are believing they're enjoying the products what we are uh, giving to them, but it is not an easy task to deliver any devices into the market. It's very tough challenge to the engineers nowadays. Okay, so there is a lack of engineers in the semiconductor field, in the material field, in RF field, any field, the less number of engineers only coming. So, as an engineer, you should focus what you know, what you already know, and what you have to do, what you have to know. That is the main thing you just have to do. Okay. Thank you all. Tomorrow class, in the next class, I will discuss about the system protection after designing the product. Thank you.